Section 12.4 discusses concentrations of solutions. Solutions can be described as either dilute, meaning that you have less solute dissolved, or concentrated, more solute dissolved. We need a way to quantify how dilute or concentrated a solution is. Those terms are only relative, but we need to be able to quantify that. So there are multiple ways to express concentration, and we are going to focus on the first two. Percent concentration will be the topic of this video, and the next video we're going to focus on molarity. Okay, there are other ways to express concentration in addition to percent concentration. Percent concentration, we can either do weight percent or volume percent. And molarity is the moles of the solute over the liters of solution, and they're the two most common ways. But other ways are molality with lowercase m, normality, capital N, parts per million, ppm, and parts per billion. 3 and 4 are not used as common, and they are used, but they're not as common as the first two. And parts per million and parts per billion are used for very, very dilute concentration amounts. Percent concentration is used widely. Most of your substances, most of your solutions, that you buy over the counter are expressed with percent concentration. For instance, vinegar. Vinegar is a solution. Okay, it's an aqueous solution of acetic acid. And I don't know if you can see it here, but see how it says reduced with water to 5% acidity? Is it showing there? I'm going to try to get the focus out. Anyway, it might not be showing it, but it says it right. It says it right there, 5%. Maybe you have a bottle at home that's a little bit clearer to see. Percent concentration. Hydrogen peroxide. 3% solution. See if I get the focus in a little better. It says it right there. I don't know if I can, the focus shows, but it's a 3% solution. Isopropyl alcohol, you combine a variety of percent concentrations. Right here is 91% isopropyl alcohol. Okay, this is a pretty concentrated isopropyl alcohol solution. And then IV solution, if somebody is in the hospital, needs intravenous fluids because they're dehydrated, a 0.9% sodium chloride solution. So percent concentration is used a lot. We're going to focus on how we do calculations with percent concentrations. Percent concentration, we have percent mass and percent volume. And typically, percent mass is calculated by taking the grams of solute over the grams of solution divided by the grams of solution times 100. Percent volume, typically the milliliters of solute over the milliliters of solution, okay, divide, multiply by 100. Remember that the solution is the sum of the solute and the solvent amounts. Now, for percent mass and percent volume, it's not exclusively grams for mass and milliliters for volume. You can have any mass unit or any volume unit as long as it is the same for the solute and the solution amounts. Okay, but typically in chemistry we see grams for mass and milliliters for volume. Now we're going to do some calculations where we're calculating the percent concentration. We'll do calculation where we calculate the amount of solute, and we will do a calculation where we determine the amount of solution. Let's look at an example. What is the percent mass of a sodium hydroxide aqueous solution made by dissolving 16 grams of sodium hydroxide for a total 55 gram solution? Now, sodium hydroxide in its pure form, it's little tiny white pellets. Sodium hydroxide a common name for it is lye, L-Y-E. And sodium hydroxide is used to make soap. No matter how expensive or how cheap the soap you have, sodium hydroxide is an ingredient that is used to make it. Sodium hydroxide is also in drain cleaner, like liquid plumber, liquid Drano, okay, those commercial products. And it's also used in oven cleaner. So let's say we needed to make a solution, okay? So when you buy sodium hydroxide in its pure form, it's little pellets. So you're going to dissolve 16 grams of sodium hydroxide to make a total 55-gram solution. What is the percent mass? Okay, well, we have our formula, percent mass equals the grams of solute over the grams of solution times 100. Okay, the amount of solute, 16 grams. The amount of solution, we're told, is a 55-gram solution. Multiply the final, multiply that ratio by 100 to get your percent mass. Okay, 16 and divide by 55 times 100. You get a 29.1% sodium hydroxide solution, and that would be the percent concentration of this particular sodium hydroxide solution. Okay, so to find the percent concentration is pretty straightforward. The solute amount over the solution amount times 100. Well, let's say we needed to find the solute amount. Let's say we know the percentage of the concentration of the solution, and we know the total amount of solution we have. Let's say we need to find this piece. Let's do an example like that. Okay. Example 2. How many milliliters of hydrogen peroxide are in a 3% solution with a volume of 946 milliliters? Basically, right here. 946 milliliters. That is the volume of this peroxide solution, this hydrogen peroxide solution. Okay, we know that it's a 3% solution, okay, when we look on the back there. Well, how much of this is actually hydrogen peroxide? It's mainly water. How much of it is actually hydrogen peroxide? Let's calculate that. So we have a volume here, a volume concentration, okay? So we have milliliters of solute over milliliters of solution. That's abbreviation for solution, SOLN, okay, times 100. So we know the percent. We know it's a 3% solution, okay? So we can just put the 3 there, all right? And we know that the amount of solute, that's our unknown. That's the amount of hydrogen peroxide we want to calculate. And we know that the total solution is 946 milliliters. And we know that we got that 3%. Ultimately, we had to multiply by a factor of 100. So we want to solve here, okay? This is what we want to solve for. Now, depending on how confident you are with your math, okay, you can convert this into its, into its decimal equivalent, okay? I'm going to show you here, you want to divide both sides by 100. That's actually what you're doing, okay? And 3% would be equivalent to 0.030, okay? And then you have milliliters of solute over 946 milliliters. Okay, so what I did here was I divided both sides by 100. Remember this 3%? You have this 3% because you multiply this ratio by 100. So now we're working backwards, okay? So 3 divided by 100 is 0.03. You say, why do you have that 0 there on the end? I just kept it because it was a significant figure with that percentage. Okay, these hundreds go bye-bye, all right? Some people may be able to look at this and go right to this step, and that's fine, but I just want to show you that 100, that we have to account for that. All right, now we need to solve for milliliters of solute, which is in the numerator. So you can think of it as cross multiply, or you can do reciprocals, however you want to do the math, but ultimately it comes down to 0.030 times 946 milliliters to give you the milliliters of solute. Do that multiplication. And you have 28.38 milliliters. If we round that to two significant figures, because that has two significant figures, it rounds to 28 milliliters of hydrogen peroxide, which is the solute. So when this was made, 28 milliliters of H2O2, hydrogen peroxide, okay, were put into this bottle, all right, or whatever container was used, and then the remainder was water to get it to this total solution volume that we have and this percent concentration. Okay, but that's how we go to calculate the amount of solute. We'll do another example where we calculate the amount of solution. Okay, let's say we have the percentage and we have the amount of solute, but what is the total solution? Okay. Let's do another problem. Vinegar is a 5% acetic acid solution. If you have 10 milliliters of acetic acid, pure acetic acid, if 10 milliliters of pure acetic acid are available, how many milliliters of a vinegar solution can be made at this concentration? Okay, so we have 10 milliliters of the solute. We want to make a vinegar solution 5%. Let's write our formula down. Milliliters of solute, milliliters of solution, times 100. Okay, we have the percent. We want a 5% concentration. We have 10 milliliters of the solute. The amount of solution is our unknown. Okay, don't forget that 100, because that's how you had your percent come out. You needed that factor of 100, okay? All right, so let's get rid of that 100, okay? So 0.0500, 10 milliliters, okay, over the milliliters of solution. Just in case you're wondering, okay, how I got from here to here, divide this side by 100, divide this side by 100, okay? 5 divided by 100 is 0.0500. I'm keeping three significant figures. Okay, now we need to solve for milliliters of solution. Watch your algebra. Some people like cross multiply, some people like reciprocal way. Whatever method you like to use is fine, as long as you do it correctly and you come out with the right answer. If you look at it cross multiply, this is the same thing over 1 if you use it, look at it like a ratio. So if you multiply this numerator times that denominator, make that the product of this times 10. Let's look at that. You get rid of that fraction. Okay, yes, you do the reciprocal way. If you do the reciprocal way, okay, you need to make sure that you are dividing both sides by 0.050, but you have to remember to bring that variable of the solution amount over. Okay, well, that's our unknown, so now we need to divide both sides by 0.0500. So that goes away. All right. So now we are left milliliters of solution is equal to 10 milliliters over 0.0500. We do that and we come out with 200 milliliters for the vinegar solution. So if we have 10 milliliters of solute of pure acetic acid and we want to make a 5% solution, okay, we can have a total 200 milliliter solution volume. Okay, and if you're not sure, you can go back and recheck. You can do 10 milliliters, which is your solute, over your 200 milliliters is your solution. Get that, and then multiply by 100, and you come out with 5%. All right. So if you were actually making this, you would take your 10 milliliters of the pure acetic acid, and you would add 190 milliliters of water to get a total 200 milliliter solution volume, and that would be a 5% concentration. Okay, so the math is very straightforward. Sometimes it's the wording that gets people confused, but when you're talking about a percent concentration, the percent of the solute, whatever unit it is it a mass unit, is it a volume unit? Percent concentration is the amount of solute over the amount of solution times 100. Okay, that's really all that it is. Okay. In the next video for section 12.4, we're going to talk about molarity. Okay, so this is just on percent concentration, section 12.4, the first part of it.